Hi everyone, welcome back to my channel. So today we will do this question, which is find pivot index. So this question is for laying the base of prefix sum pattern. So this is a very easy question, but we will understand the pattern well with this question and then implement it to more difficulty level problems. So if we look at the question says that given an array nums, calculate the pivot index of the array. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to sum of all the numbers strictly to the right of that index. Which means if let's say this is the input array, we are given output as 3, which means 3 is the pivot index, which means left sum is sum of indices at 0, 1, 2 is equal to 11, and right sum, which is index 4 and 5 is equal to 11. So the pivot index comes to be 3. So this way we need to find this pivot index and return it. Now let's understand the question and this pattern. So we are given an array nums and we need to find a pivot index I where sum of left of I and sum of right of I both are equal. So this is the question. Now if we think about naive solution of this, what we can think is that okay, we need to calculate sum of elements from left and elements from right, and at any point if they are equal we will say that this is our answer. So for naive solution, what we will do is we will have a loop from I 0 to n minus 1, and for each I what we will do is we will calculate left sum and right sum. For left sum, we will run a loop from 0 to I minus 1, and for right sum, we will have from I plus 1 to n minus 1. And we will compare if left sum is equal to right sum. Then we need to return this I. Else, if after running all these we don't have anything, we will return minus 1. So this is naive solution. Let's see how we can code this. For coding it, what we'll do is we will have a for loop. We will have a left sum variable and a right sum variable. We will run a loop from, let's say, L is the loop variable, L is equals to 0 to L less than I, because let's say L is here, we need sum of the left elements, L plus plus. We will have left sum is equals to adding the L pointed variable. For right sum, we will have a loop r is equals to I plus 1, r less than n, and r plus plus. And in this loop, we will have right sum calculated. So this is right sum. Now we need to check if left sum is equal to right sum. In that case, we will return I. Now this loop is completed, and at last if we have no answer, then we will return minus 1. So this is naive solution. What we will have is we will have I pointing to, we will have initially I pointing to first element. So the left sum will be 0 and right sum will have all these elements. Then I will move forward. Left sum will be having this element and right sum will be having this element. This way I will keep moving forward, and we will have left sum and right sum, and we will compare it. If we at any point we have answer, we are returning that answer. So we are returning leftmost answer. Now let's see how we can optimize this. So the time complexity of this solution is order n square, because we have an outer loop and inner loops. But space complexity is order 1 because we are not using any extra spaces. So because we are recalculating sum again and again for every index, so this is a naive solution. So how can we optimize this? Instead of calculating left and right sum again and again and utilizing the complexity of order n square, what we will do is we will use a total sum. and a left sum, which will be running sum from left. And what we'll do is, let me explain it. So we will have a total sum, which will be sum of all elements, and a left sum. And from these two, we can derive the right sum. So right sum will be total sum minus left sum minus whatever is the current index, because we are not including the pivot index. And then we will check if left sum and right sum, they are equal or not. So what we will do is, first we will calculate the total sum. Then we will initialize the left sum to 0, and we will run a loop through array and calculate right sum, which is equal to total sum minus left sum minus whatever is the current element. And at any point, if left sum is equal to right sum, we will return this I. We will also update the left sum. So this is the point, that we will calculate the total sum and we will run a loop and calculate the running left sum. At any point, we don't need another loop for calculating the right sum, because we have the total sum, and right sum is equals to total sum minus left sum minus the current element. So utilizing these facts, we can find the pivot index without having order n square as time complexity. We can do this in order n, because we will have only this loop running. This will calculate the running left sum and have the right sum by this particular formula. So let's code this. So we will have a total sum which is equal to 0 initially. We will run a loop for calculating this total sum. So this will have total sum. Suppose the array is 1, 2, 3, 4, 5. So this will have sum of all the elements. After this, we need left sum. Initially, we keep left sum as 0. Now we will run a loop, and in this loop, we will calculate what is the right sum for current index. Initially, I is here, left sum is 0, and right will have all these elements. So for right sum, what we will do is total sum minus left sum, which is currently 0, minus nums of I, which is currently this index. So we are subtracting this particular index from the total sum to get the right sum. And we will check if left sum is equal to right sum. We will return this I. In this case, it is not equal. Now this thing is evaluated. Now we need to have the running left sum. So for that, what we will do is left sum. Now the left sum will have 1 in it. Now I will be incremented and reach till here. When I is here, we have left sum this and right sum will be this, and both will be compared. Then I will move further forward, left sum will be this and right sum will be this. So this way we will have left sum and right sum with having order of n as time complexity. If such a sum doesn't exist, then we will return minus 1. So this way, this is our solution. Let's code this. And in this, we are not using any extra spaces. After doing this question, if we summarize what is prefix sum, so prefix sum, this is a pattern in which we pre-compute sums so that you can answer range queries in order 1. So we do some pre-computation. So this pre-computation avoids the extra time complexity. It's mainly used when you have multiple subarray sum queries or you need fast range calculation. If we see phrases like sum from I to j, or range sum, or subarray sum equals to k, or contiguous segment sum, in this case, this particular pattern is usually used. So what we have is, let's say we have some array and we just need some pre-computation, so we can keep on adding this. Some, for example, in this question we had total sum. So this way, in these type of question, we use this pattern such that we do some pre-computation in advance. As we done previously, we will have a total sum. We will calculate the total sum. We will have a left sum. We will run a loop and calculate right sum on the fly, which is using total sum minus left sum minus the current element. And if any point we have the sums as equal, we will return that sum. And if not, we will update our left sum. At last, we are returning minus 1 because we have not found any such condition answer. Now let's run this. Let's submit this. So yeah, we have our solution. So this is a easy level question. We will increase the complexity eventually. This is to learn pattern from basic to advanced. So thank you. If you find this helpful, please subscribe to my channel. Thank you.